Hello, my name is Isa Lee, and I did my final project on dual photography. Dual photography is a paper published in SIGGRAPH 2005. It introduces a version of a really cool photographic technique making use of the Helmholtz reciprocity. The Helmholtz reciprocity states that a ray of light and its reverse ray encounter matched optical adventures, such as reflections, refractions, and absorptions in a passive medium. In this case, this specifically means that if we have a stack of special photos, which I'll get into later, taken of a scene lit by a projector, we can use the light detected in captured images to calculate the light path and reconstruct an image taken of the same scene but from the location of the light source. In other words, we can get a photo with the location of the camera and the projector swapped. As a bonus, since we know what the light going through each pixel looks like, we can also relight the scene with various different lightings. So looking at this figure on the right, we notice that this T translation matrix is very, very crucial to the entire process. Once we obtain this T matrix, we can just transpose it, and then that will help us essentially reverse the light and swap the location of the projector and the camera. To obtain the T matrix, the paper suggested 3 ways to do so. The first one is that we can just light up the pixels, each pixel of the projector one by one, but this will require a lot of images being taken. Even for smaller photos within 200 by 200, which is what I worked with for this project, we will need 40,000 photos to be taken and processed. A second method is that we can parallelize this process by dividing the entire frame into 8 by 8 blocks and illuminating only one pixel of the block at a time. To figure out which projector pixel is lighting up the scene, we also display temporally the binary number corresponding to the block. This means that we need to take log n photos for each of the 64 pixels of a block, where n is the total number of blocks. And finally, the third way is to recursively partition the entire frame into 2 by 2 blocks and examine the blocks that do not interfere with each other in the scene. This method needs us to recursively divide and test the blocks, making use of graph coloring to find blocks that are not adjacent to each other. I tried this method but was unsuccessful with it, so I turned back to the second way that I mentioned. When actually implementing the technique, I manually took all the photos. I worked in the grayscale space as the projector was displaying inconsistent colors. The paper itself was a little complicated and left out many details in terms of implementation. I had a few failed attempts, which I've explained with more detail in my report, but below is one of the attempts I would like to highlight. In this attempt, I did not adjust the correct camera settings, with the darker spots being too light and the lit up portions being overexposed. This resulted in it being very hard to distinguish the original shade of the object as well as the depth of multiple locations. After a few more attempts, it eventually worked. I realized that the camera setting needs to be adjusted so that the original scene is relatively dark while the light up pixels are easy to see without overexposing the scene. To achieve this, I used a relatively lower ISO at about 400 in a completely dark room, as well as a very small aperture size, and I compensated for this by increasing the shutter speed. And I also realized that when I'm projecting a pattern onto a scene, the places that are black in the photo are not truly black when being projected. It's still being lit up, just very dim. So I compensated for that by decreasing the exposure manually by a factor of 3.7. And so here are the demo. Overall, I think this is a very cool technique that is relatively easy to implement, but will require certain equipment to reach the effect displayed in the paper's official demo video. Again, there were many ambiguities in the paper, and part of the challenge to this project is essentially guessing and checking, fine-tuning all the decisions in order to reach the best result. And I've detailed them in my report. Thank you for listening.